So in this problem, we're starting with the graph of a line. So that's what's given to you. And the question wants you to determine an equation for this line. Since it doesn't say what kind of equation, we get to pick. Right? If we wanted to, we could shoot for a standard form equation, ax plus by equals c, if we wanted to. Chances are that's not the choice that you made. It's also not the choice that I would make. I would probably prefer, as you did, to shoot for a slope-intercept equation for this line instead. Y equals mx plus b. After all, that's the form of an equation that most of us remember at the top of our heads for a line. So let's try and finish there. We're starting with the graph of a line in the purple square. We're trying to finish with a slope-intercept equation for that line in the green square. So what did you do? How did you begin this process? Someone give me their first step.
Listed the points that were already plotted.
Yeah. So the graph has kind of helpfully here labeled 2 points that are on this graph. So let's write out the coordinates of those 2 points. And what that's done for us is it's taken us out of the graph land and it's taken us into the 2 points land, right? So we've already taken a step on this little flow chart. If we write out the coordinates of these 2 points. We started with the graph, and after writing the coordinates of those 2 points, we're going to have taken a step up here, right? So we'll now have 2 points to work with, and we know what to do once we have 2 points. So what were the coordinates of the 2 points that were labeled on this graph? All right, so the first point that's labeled here is x equals 0, y equals -1. So that happens to be a point on the y-axis. And the coordinates of the second point? 5, -2. So you would have had to go through some counting of grid squares to get that, right? For example, 5, -2 you might have gotten by starting at the origin, counting 5 steps over in the x direction, and 2 steps down in the y direction. That would give you the coordinates of that point, 5, -2. Okay, so there's the coordinates of those 2 points. So now we're up here on our diagram. What did you do with those 2 points? What was your next step? Yeah. So the next step, really kind of the only thing that we can do that's new from this point in the flowchart, is to go from the 2 points to their slope. Right? We can't go directly to the slope-intercept equation, but we can go directly to finding their slope using the formula which defines slope, rise divided by run. So step 2, compute the slope by dividing rise over run. So we have to find what the rise and the run are. x2 minus x1. So what was the rise, did you say, connecting these 2 points? Or how did you find it? Okay. This is a great place to make a sign error, by the way, because we're taking these 2 y values, -2 and -1. If I call this second y value here y2, this first y value here y1, then what I'm subtracting is y2 minus y1, -2 minus -1. Again, great place to make a sign error. Let's try and avoid it. What is -2 minus -1? -1, yeah. Because it's the same as -2 plus +1. So -1 is what we get in the numerator up here. Great place to make a sign error. Try and avoid making that sign error. So that's what the rise is. What about the run? What's going to be in my denominator? 0 minus 5. Is that what everyone had? Uh-oh. Another great place to make an error, right? Whatever ordering that we select for our points has got to be consistent between its x-coordinates and its y-coordinates. So if I chose -2 to be my second y-coordinate and -1 to be my first y-coordinate, as I did here, that means I need to choose 5 to be my second x-coordinate and 0 to be my first x-coordinate. And so rather than 0 minus 5, what I want is 5 minus 0. Another way to keep that straight is to make sure when you look at your slope formula that the matched up coordinates are directly above one another. So 5 comma negative 2 is right there above one another in the slope formula, and 0, negative 1 right there above one another in the slope formula. So that avoids the error of exchanging the ordering of the points between the x's and the y's. So my denominator ends up being 5 minus 0, otherwise known as 5. So what's the slope of my line? It's negative 1. So we've made it starting from the graph of the line. We identified 2 points, the coordinates of 2 points. Then we use the slope formula to discover what the slope of this line is, negative 1/5. So now what can we do with that information? What was your next step in this process? Emma?
Plug it into y equals mx plus b and then plug it in.
Okay. So you plugged it in, it being the slope,
Yeah.
into y equals mx plus b. And so where in that equation does this number go?
M.
Yeah. I don't know what weird twist of linguistic fate, by the way, made m the abbreviation for slope. I think it must have come from a different language or something. There's probably some story behind it. But yeah, m stands for slope for some reason that I don't know off the top of my head. So we will put negative 1/5 right there in its place in the equation. So now the slope is in place, and we've got half of a slope-intercept equation. What else do we need? We need the y-intercept. How are we going to find the y-intercept?
It's already plotted for us.
So here we get real lucky. Yeah, we can take the shortcut. The y-intercept already exists on this graph. Where do we find it?
On the y-axis.
Yes.
Couldn't you just like browse over run in the beginning and just like skip all these steps?
Well, I'm not sure what you mean. We'll revisit that question in a minute. For the y-intercept, it's already been labeled for us. It's the point on the y-axis in this example. So what's the value of b for our line?
Negative 1.
-1. The y-coordinate of the point at which this intercepts the y-axis. So then the last thing is just to finish my equation. Now we know that the slope was negative 1/5, and we knew that the y-intercept is negative 1, so y equals negative 1/5 x plus negative 1. So I'm just going to write that as -1. Completes the picture. So you're asking, could we have skipped step 1?
Yeah, and just come to them.
Sure. Yeah, absolutely. The reason I like not skipping step 1 is that sometimes step 1 is where the problem begins. Like if you don't have a graph to begin with, and you just have the 2 points, that gets us the practice using the formula. But you're absolutely right that we could skip having to specifically write out the coordinates of these 2 points just by going over to the graph and saying, well, how do I find the slope of this thing? I need the rise, I need the run. So let's look at the run. To get the run, I'm just going to go horizontally from the first point to the second, and notice that I'm going 5 steps to the right. And so that must therefore be a run. Here's that 5, by the way, right here. And what about the rise? Well, in addition to going to the right 5 steps, I also have to go down 1. So 1 step down. And so my rise has got to be negative 1. And we get to the same slope, right? So even though I prefer not to skip that first step of writing out specifically the coordinates of these 2 points, it's certainly very doable just to get at the slope by measuring rise and run directly from the graph. So here's a reason why you might want to label the points rather than just relying on counting grid lines to find the slope of a line. If I'm doing part F, here I have a line which is being graphed, and I might want to, again, follow the same kinds of logical steps in order to find an equation for this line. That's what I'm being asked to do. So I'm starting in the same place as we started before. We're starting by having a graph of this line. And what we want is we want to finish by obtaining a slope-intercept equation for this graph. So starting here, we want to end there. So along the way, we have to find the slope. Let's suppose that I skip the step of labeling the coordinates, and I go directly to finding the slope. How would I do it in this line in part F? Chances are what I would do is just start counting 3, 4, 5, 6. So I'm starting from the point on the left, I'll count 6 grid squares to the right. And so that tells me that my slope is going to have a 6 in the denominator. And then counting upwards, 1, 2, 3, 4. 4 steps up, which tells me my numerator. And so the slope of my line is 4 over 6, which is better known as 2/3, written in lowest terms. So in a way, we can kind of skip the step of labeling the coordinates of the points and go directly to the slope. The problem is in what happens next. Because according to the example we just did previously, the next thing that we should be doing after we find the slope is to plug that slope into the y equals mx plus b equation. So if I do that, I'm going to get y equals 2/3 x plus some y-intercept that we don't know. Now in the previous problem, we could read the y-intercept directly off the graph. In this example, well, we can guess. Based on what you see in this graph, what does it look like the y-intercept is? Yeah, it looks like the y-intercept is 4. But anytime you're working with a graph, my word of caution is that while pictures speak 1,000 words, they don't always speak them clearly. We don't know, just by looking at this graph, whether that intercept is 4 or whether it's, I don't know, 3.96 or 4.05, right? It could be something close to 4, but not exactly 4. And a graph, no matter how precisely drawn, is not going to give you the level of precision that algebra and arithmetic will. So, my recommendation is not to believe your eyes, or at least not to trust them completely. What other way do we have, using algebra, to determine what this y-intercept is? How do we find b if we don't think that we can trust what we see on the graph?
Pick one of the points and then plug them in for.
Yeah, so there's the way to not just trust, but, as Ronald Reagan used to say, trust but verify. So how we verify that b equals 4 might actually be the intercept is let's plug in. Pick either of the 2 points, as you said. Select whichever one you happen to like. Plug in one of the known points into this equation as x and y, and then use that new equation to solve for b. And this is the stage at which we would, no matter how hard we try, we would have to actually write out what the coordinates of at least one of those points is. So maybe I would go and look at this point on the left, measure its coordinates as -3, 2, and then I would use -3 for x and 2 for y to then give me an equation that I can solve for my y-intercept b. So then I'll multiply 2/3 by -3, which we can do by multiplying them as fractions, times 3 over 1, and then reducing. -3 divided by 3 is going to cancel out to give me -1, so that fraction evaluation is going to be -2. And then solving for b requires adding 2 to both sides, and sure enough, we find out that b was in fact 4. So, it's not as though we would have gotten the wrong answer by trusting that the graph was accurate and that the y-intercept is in fact 4. But I could very easily envision examples where the y-intercept isn't exactly what it looks like on the graph, and the algebra is the way to know for sure.